Hello everyone, how are you guys all doing today? My name is Bryce Easton, and I am your SAS tutor for EP1. So I haven't had a chance to meet a lot of you, unfortunately, but I'm going to give you guys all a quick rundown on what SAS tutoring is. So basically, SAS tutoring is a collection of students that have previously taken these classes and have done significantly well in them. And basically what we're doing now is we've come back, we're re-going through them, and we're basically here to help you guys out with any questions you have, such as helping you review for these tests. And also if you have any questions like questions on homework or concepts or anything else, please come by. Our room is 1112 in the engineering building, or go under Teams. I will show you how to get onto Teams right now. So you're all in EP1, which means you should just be able to search up law. He sent a message out earlier. I'm not sure how many of you were able to see it, but pretty much you just gotta search for it. It's right here under SAS Tutor, so you can probably have also searched up law SAS. But you just take this link, click on it. I would advise eventually downloading the web app, but you can, or the Windows app, but you can use the web app. That's perfectly fine. That'll get you here. In addition, if you're taking any classes like any of the calcs or the chems or macro, those are also good. And this will also be the same website that's used for if you go on to EP2 after this. So I would recommend getting on here at some point, even if you don't think you need help with this course. But yeah, so you go on here, you would go to Physics 213, and that's where we have the questions, stuff like that. Once again, post whatever question you have, or come into my office, or come into SAS 5:30 to 7 o'clock Wednesdays, or 4:30 to 6. That's when I'm there in person. But anyway, we're going to get on to the test now. So this isn't the practice test or the test that any of you likely were to have seen before. This is from fall 2017. However, law did teach that, so this should hopefully be still useful. First thing I would always say is go down, for any test, go down, look at the equation sheet. These are very useful, especially these equations. We're going to be referencing them a lot. But pretty much what you want to do is if you have a test, if you can, detach, tear it out, have it side by side when you're going through the test. And this test is open notes, so I would say there's no excuse. You should have these equation sheets out and by your side. But yeah, we'll revisit a lot of these as we go through the test. So without further ado, let's get on with this. So this first question here has 4 paths, and it wants you to rank them in order of average velocity. So average velocity is going to be equal to your ending x minus your initial x over the time. So in order to do that, we just take a look here. We see that 1 goes up, x1 minus the x0 is only 1, so we have 1. We have 1 here, 1, and 1. So all equal. The next part has speed. So the main difference in speed is distance. So whereas velocity mainly it depends on the endpoints, speed wants to know the whole distance. So for 1, we go up 2 and then go back 1. So even though we're going back, we don't take away from our distance, and we instead add it. So we get 3. Similar here, we have 3. And right here we have 1. And right here we have kind of all over the place, but I think that's 5. So that's the main difference between speed. So this one would be 4, 1, 2, and then 3. So you can see that the velocity, it does matter if you're going backwards. Speed, it does not. As long as you're moving, it doesn't matter the speed. So now let's do number 2. So you dropped an egg off the edge of a building. So key is drop. It wants to know what curve represents the dropped egg. The curve is this one. So dropped egg, that means that if it's dropped, that means the initial velocity, well, that's terrible, is going to be equal to 0. So that means that we just need to look for one where it starts at 0. That's D. So our answer here is D. Now for part B, we have one that's thrown from the same spot. So even though it's in the same spot, this is a velocity versus time graph. So we're going to expect it to have a negative starting point because it starts off going downward. So it's going to have to be one of these. In addition, gravity is acting on it, so it's going to go down at a negative that crosses off B. And now we just have these two. And to keep in mind, now we determine, so the answer is going to be E. We know this because the thing pulling it down, making it decrease, is gravity. And gravity is also acting on the dropped egg. So they're going to be decreasing their velocity at the same rate, even though this one starts lower. So that's how we know it's E, because these two are parallel. Let's move on to number 3 now. So number 3, we have the velocity, this equation here. And pretty much what I want to say here is, this is going to be right-hand rule. Since I'm not here, I'm not really sure I can show you guys it. But pretty much, this one's going to be in the positive x direction, so you can practice on these. Positive z. Positive z. But one thing I can say is that when you have an x and y like we do here, x and y like we do here and here, that means we're always going to go to a z. And when we have a y and z, or a y and z, we're always going to go to an x. And when we have an x and z, we're always going to go to a y. So if that helps you at all with the right-hand rule, and also remember it's right hand, so use your right hand. But yeah, unfortunately this is not one of the ones that I'm best able to explain over a recorded lecture or review. So we're just gonna, this is the answer. We have positive z, and positive x. And now we're gonna move on to number 4. So right here, the main thing that they want you to know is that cross products, so when you cross, you're going to get a vector, but when you do a dot product, you're going to get, oh, yeah, that was a poorly, you're going to get a value. So let's call a value x. So let's go through these one at a time. So we have a, that is a vector, cross product. We're going to add that. And the cross product is going to be a vector. Since you can't add vectors together, A is good. Now for B, dot product, we get a value x, which is 5, plus a value x. So since these two are both values and not vectors, we can add them. Now up to C, we have a value x added to a vector, since it's cross, so that one does not work. Likewise, we have a dot product B, which is a value x, and we have BC, which is a cross product, which gives us a vector, so we can't add those together, so that does not work. However, let's do a quick hypothetical. Say instead of a plus, this was a multiplication, and we were multiplying a number by the vector. That would work because you can multiply a number by a vector, so that would be good, in case you see that on the test. Alright, but hopefully that makes sense. Let's move on to number 5. Alright, so now let's look at so this one, we have a balloon rises vertically at an initial speed of 10 meters per second. So this is 10 meters per second. Yeah. And we can see that it detaches after a certain time and then starts to fall downward. So we have the package. It's going up. After a while, it breaks free. So when it starts breaking free, it starts then going back down. So it breaks free at this point, still going up, it's slowing down, and then it starts going down. So the first thing they want to know is which times the package is moving at constant velocity. Right here we have the velocity versus time graph, which tells us how fast it's moving in terms of speed. So if it's a constant velocity, they want to know when the velocity is not changing. So at this point, the only times when the velocity is not changing is when it's flat, and that's right here from 0 to 2. So that's our answer for this one. Next they want to know when it's moving at a constant acceleration. So constant acceleration is whenever it's flat. That is, or constant acceleration is whenever the slope is constant. So, the slope is constant from 2 to 8. And then, depending on who the teacher is, they could also say that 0 to 2 is constant because the slope is 0, and thus the acceleration is 0. Even though it's 0, it is still constant. So this would be your answer, 0 to 2 and then 2 to 8. Do not put 0 to 8. If you put 0 to 8, that would be incorrect because there is a change from 0 to 8. So 2 to 8 and 0 to 2 is your answer here. So now we're on part C. We're going to use the graph to determine the acceleration of gravity. So in order to do that, we're just going to take 2 points and going to calculate. So they want to know the acceleration. The acceleration is the slope. So we take the 2 points and we just calculate the slope. So that's 10. We go down 10 seconds over 2 seconds. And that gets us -5 meters per second squared. And that's our answer. Hopefully that makes sense. They also want to know when the graph is starting to break free. That's pretty much when, so before the balloon was keeping at a steady pace and a steady velocity. So when it starts to change, that's when it breaks free. So 2 seconds is our answer here. And then they want to know how high it is above the ground when the package breaks free. So to determine the height of something, you want to take the starting height, which is 0, and then add it to the area under the graph at that the area under the graph to that time. So under the 2 seconds, we have 10 multiplied by 2. We got this area here. That is 20. So our answer here is 20. And make sure you include the units, meters, because they will count you for points if you don't include those units. I learned that one the hard way when I took it. At least for the, Anyway, so that's the answer for part C, or part E. We are now in part F. They want to know at what time is the package at its highest point. Once again, we're going to go up to the graph. Now you might think that it's at 2 seconds, since that's when it's moving the fastest. However, even though it's slowing down, at this point, the velocity is still positive, which means it's still going up. So this point isn't the point where it's at the smallest. It would actually be this point. When the velocity is equal to 0, we get the max. So velocity is equal to 0 at 4 seconds. So the answer is 4 seconds. And yes. And then they want to know how high the package is above the ground at the highest point. So highest point is at 4 seconds. We just need to calculate the area under the graph from here to here. So we already know that this is 20. We just need to calculate this, which is 10 multiplied by 2 divided by 2. Since it's a triangle, we get 10 meters. We then add that 20, which we have, to the 10, and we get 30 meters. Hopefully that makes sense. And if you think about it, because if you keep going, this will be negative, so you'll be taken away from the area under the graph. And if you did it earlier, you wouldn't have as much area under the graph. So this reinforces that this is the highest point at 4 seconds. And now for the last part of this question, we need to use the graph to estimate the velocity on which the package hits the ground. So in order to do that, we're going to go down to the table, and we're going to use this equation. So the V final is equal to the initial velocity, which is 10, plus the acceleration times the time. So our time is going to be the total time it took to fall, which is 6 seconds, 8 minus 2. And our initial velocity is going to be 10 meters per second. And the acceleration is what we already calculated. And then we just plug that into the equation. And we get 10 minus 6 times 5, 30, which gets us 20 meters per second. And don't forget this is negative. And that's our answer. So that's 5. If you have any questions, post it in Teams, where I will try to answer it as soon as possible. So now let's move on to 6. So in number 6, we have an armadillo that leaps upward. We know the distance it moves. What we're going to do is once again go down to the equation sheet. This time we're going to use this. So the equation of this one is basically the distance traveled by x, or in this case the 0.6, is equal to the initial velocity times time plus acceleration times time squared. Acceleration in this case is gravity, so a equals negative 9.8 meters per second squared. If they don't give you a value for gravity, always assume it's negative 9.8 or negative 10. So yeah, we plus that. And AT squared is going to be divided by 2. We then plug our t value is 0.2, or change in x is 0.6, so that gives us times seconds minus 4.9 times 0.49 times 0.2 seconds squared. After that, all we have to do is simplify out. So we're going to multiply this through and then add it over to this side. That will get us 0.2 V0 equals 0.796. Divide this over, we get V0 is equal to 3.98 meters per second. Alright, hopefully that makes sense. Now we need to, on to this next part, we need to determine the armadillo's speed and height, 0.6. So we're going to go back up to this equation. Fortunately, we already have the So our V final, which is our speed at height 0.6, we already know the time at 0.6 is 0.2 seconds. Our initial velocity we just calculated, so we have all of this minus 9.8. And then all we have to do is just simplify this out. And we get 2.02. So, and that is meters per second because it's velocity. So now we're on C. We need to determine the maximum height. So in order to do that, we're going to go down to the equation again. And this time we're going to be using this one. If you want to know how I know which one to use, well, honestly, a lot of them can be used for a lot of the different ones. But the rule for which ones to use, or you should already know every one of the equation, every one of the variables, except for the one you're trying to solve for. So anyway, we have this equation. So we're going to go back up. Squared equals and then go back down to double check. Plus 2 acceleration times the total change in x, which is going to be our x height. So this is what our equation looks like. The final times squared equals the initial squared plus 2 times the acceleration times the height. So now remember what we talked about in the previous one is that the maximum height is always going to be when the velocity is equal to 0. So we can set Vf equal to 0. And with that, the only value we don't know is xh. So we just plug in our values, and we're going to subtract this one over because the a is going to be negative. We're going to get negative 19.6 times xh is, well, this one will actually be positive, since it's now on this side, is equal to the initial velocity, calculated up there, times 3.98 meters per second squared. And from this point, all we have to do is finish up the calculations. And we get our final height of 0.81 meters. And then in part D, they want to know how long it takes the armadillo to go to this final maximum height. So once again, I'm going to suggest we use this one v final, which equals 0, equals v initial plus acceleration times time. We just take 3.98 divided by the acceleration of 9.8, and we get our time point I'll go back real fast and show how this one, the V0 is 3.98. And then we add, since this is equal to that side, we added this over and then divided it out. Pretty much the main rule for a lot of these problems is if you can figure out the right equation to set up, the rest is pretty much just adding, subtracting, dividing, and multiplying. So if you can figure out, get down which equations to add in, you're pretty nicely set up. So in this 7 part, we're going to, they want us to do a rough sketch of A and B. So pretty much you can see that let's do A first. So I is code for X, J stands in for Y, and even though it's not here, K, if you run across K, that stands for Z. So those are the three things. So right here we can see that A goes 4.2 across, negative 1.5 down, and now imagine I drew a straight line. And then this is the rough sketch of A. And you're going to have this one be 1, 3, 4, and then it's down 1.5, and then we have B, which is going up at a 10-degree angle. Yeah, this one works a lot better on paper instead of on this, 10 degrees. So we have 10 degrees there, and then even though we don't know how far it is in the X or the Y direction, we do know the hypotenuse is length is 7.5. That's what it means to have the magnitude. But anyway, this is the part A. It's mainly just setting up everything that we're going to be using later. So first thing we're going to do is do the magnitude and direction of the vector A related to the x-axis. So first for the magnitude, we're gonna sketch A that comes out like this. So A goes down like this. We're trying to find this A value, which is the hypotenuse. We currently know the AY and the AX. And when you know the two legs, the answer you're going to get when you know the two legs, you try to get the hypotenuse. The thing you have to do is just take the legs and square them, so you get ax squared plus ay squared. And this time you don't have to worry about the ay being negative, because the square is going to cancel that out. And that gives you a, which is also your magnitude. So, if you plug your values in, you should get something like 4.46 for your magnitude. Now for direction, we're trying to figure out this direction here. So if you remember sine, cosine, all we really want to do here is just take the sine. So we want to set up the equation to figure out this angle. Since we know the hypotenuse and the opposite, we can set up a reverse sine equation to calculate it. So sine theta equals AY over B. And that, AY over A, not so I should be, I'm getting a little ahead of myself. Yeah. So that, at that point we just put A here, we plug this A value in, and we plug the AY value in, which is negative 1.5. So we do negative 1.5 divided by 4.46, and that gives us negative 0.336. We're then going to take the sine to the negative 1, because we need theta by itself, of both sides. That's going to give us a degree value of negative 19.65. So, now we all know angles can't really be negative. So that's why I will say that playing with negatives can be kind of risky. However, since we're trying to do it from the positive x-axis, this still works out because this one is 19 degrees. It's just facing downward. So a positive 19 degrees would be facing upward. So we can here just put negative 19 degrees, 0.65. And that's our answer. Degrees. So now we're on to part C. What we're going to do, so just like with the previous one, we're going to draw it out into a right triangle. This is BX. This is BY. And this is B. Now it's the opposite of last time. So this time we know the magnitude, which is B. But we need to figure out the X and the Y components. So we also know theta, which is 10 degrees. So pretty much what we want to do is a little bit of trigonometry. So we have sine theta which equals sine 10 in this case, is equal to opposite over adjacent. So equal to by over b. So what we want to do then is plug in our values, and we get by is equal to 0.17 multiplied by 7.5, or sine of 10 multiplied by the magnitude. And that gives us 1.3. Hopefully that makes sense. And now we're going to move on to the x. So the x is the same, only instead of opposite, it's adjacent. So we're going to construct the same model, just with cosine. So cosine 10 is equal to bx over b, and then we're just going to plug those values in order to get our answer of bx equaling 7.39. Hopefully that made sense. But yeah, if not, please let me know. In essence, it's basically just triangles. You just need to do cosine to find the adjacent and break down the bigger one. Alright, so with that, I'm going to move on to D. That one's the dot product of A and B. So the dot product of A and B is just AX times BX plus AY times BY, which is then, we just need to substitute our values in. So bx is 0.339 times 4.2 minus, because 1.5 is negative, 1.7 times, 1.3 times 1.5. And that gives us our final answer of 29.1. Hopefully that made sense. That's the dot product. And now we're going to go on to the magnitude. and cross product of A cross B. Hopefully we can get this done before we reach the hour mark. After this, we only have one question left. So let's power through. So magnitude of direction of cross product. So cross product means we always want to set it up like this, with each vector having its things on top and bottom. We have AX, AY, BX, BY. And now we're just going to, hopefully you all remember how to cross multiply. We do this one subtracted by this one. So we got AX BY, that's a Y, subtracted by AY BX. So now we just need to plug in our values. So we got 4.2 multiplied by 1.3 minus negative 1.5. So the negatives will eventually cancel each other out. Times 7.39. And then all we have to do is just plug these answers in. And we should get 16. Oh, that's direction. 16.545. And now, and they want to know direction. So direction, whenever you have an X and Y, it's going to go to Z. So that means we have in the Z direction. And since the magnitude ended up positive, that means it's going to be in the positive Z direction. This is also a little thing. If the magnitude had ended up negative, so let's say we had negative 16, then the direction would have ended up being negative, but the magnitude still would have turned out positive, because magnitude can never be negative, only the direction can. However, this time it is positive. So, that's 7, and we're on to the final problem. In this one, a red train is traveling at 72 kilometers per hour, and the green train is traveling at 144 kilometers per hour. They see each other when they are 1,050. That looks like a 6. 1,050 meters apart. And blah, 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 blah. Oh, they see each other. And they start to slow down at an acceleration of negative 1 meter per second squared. And they want to know if they stop in time. So what this basically is a distance equation. You want to know how far this train moves and how far this train moves, and do they move far enough to collide. However, there's the first thing we need to do. This is a good thing for tests. Always make sure they're in the same units. So we have meters, seconds. These are kilometers. Kilometers need to be changed to meters. So we're going to multiply these by 1,000. We're just going to do this one first. So we got 14. Multiplied, and then we also need to multiply this by 1 hour over 3,600 seconds in order to get from hours to seconds, because we need the same units for time. And this will leave us with 40 meters per second as the velocity. And I would have to do the same thing for this one. However, I'm pretty lazy. And I know that this is 72 is half of 144. So I know that this is 20 meters per second. I would say that in an actual test, go through this calculation as well. It's pretty much the same. Yeah, but yeah, always make sure you convert the units to the same units. And yeah. Alright. So, now what we're going to do is calculate the change in distance for the red train, the first train, which is moving at 20 meters a second. To do that, we're going to go down to the distance equation. So this one, which is equal to initial velocity times time plus the acceleration times time squared over 2. So we know the acceleration. As for time, we know it's slowing down at 1 meter per second. If we start at 20 meters per second, we're slowing down 1 at a time. We just divide the 20 by the 1. We get 20 seconds. So, hopefully that's great. Okay. And now we just plug our values in. So, and this will get us to our final value of 200 meters. Yeah, you can check the algebra if you'd like, but it's pretty simple. I mean, it's, yeah, 400 times 0.5, we get 200. And now we're going to do the same thing for the green train. Exact same thing, only instead, the initial velocity is going to be 40 instead of 20. As a result, the time is also going to be 40. This initial velocity would be nice to write out. So now we just plug our value in. and we get 40 times 40 minus 40 squared over 2, which gives us our final distance moved for the green train of 800 meters. So we have an 800 meter and we have 200 meters. So now we just have to combine them and figure out, do they collide or not? So xg plus xr is, let's xr is equal to 800 plus 200, 1,000. So 1,000, since 1,000 is less than 1,050, we can say that they do not collide. And they want to know the distance between them. Subtract the 2, we have ourselves 50 meters. And that's a solution. That is also the end of the test, with only a few minutes to spare before we reach the 1 hour mark. So thank you. Once again, the test after this will be better. Reviews, we'll have more time to prepare and stuff. Yeah. So anyway, good luck on the test, everyone. And if you have any questions, once again, go to your mail, search up law, or you can probably search up SAS. Well, it's not good for me to search up SAS because I got a lot of emails, but yeah, it should be one of the first ones that comes up. And yeah, just click on it. It'll take you, it should hopefully take you to this. And yeah, you can post. And yeah, if you have any questions, you can hear, or you can directly chat. I think you can, yeah. Anyway, I hope you all do well on the test, and good luck. Yeah, let me know, and hopefully it goes well.